In last lecture we saw gradient and obtained the expression for the gradient. Now in this lecture we are going to see divergence. So today's topic of discussion is divergence. In last lecture we saw this del operator. We obtained the expression for del operator. Now if I take dot product of operator del with some vector function f bar, now f bar is vector function. What is meant by vector function? It contains direction inside it. So it is a vector function, and if I take dot product of del bar with f, then it will be the divergence. Now I can write f bar as f1 e1 cap plus f2 e2 cap plus f3 e3 cap, where f1, f2 and f3 are along e1 cap, e2 cap and e3 cap, and f1, f2, f3 are components of f bar, function f. Okay, these are the component of function. Now if I take dot product of del bar with f bar, then I can write it like this: del bar dot f1 e1 cap plus del bar dot f2 e2 cap plus del bar dot f3 e3 cap. So f3 e3 cap. Here will be dot product. And in last lecture we saw that del bar of u1 is equal to e1 cap upon h1, del bar of u2 is equal to e2 cap upon h2, and del bar of u3 is equal to e3 cap upon h3. We obtain this by saying that if psi is u1 and then we operated del bar on psi, that is del bar u1, and we got e1 cap upon h1, e1 cap upon h1. Now if I take cross product of del bar u2 cross del bar u3, then I can write it like this. I will use these values. So e2 cap upon h2, del bar u2 is e2 cap upon h2 cross e3 cap, del bar u3 is e3 cap upon h3. So this can be written as e1 cap upon h2 h3. So the cross product of e2 cap cross e3 cap, it will be e1 cap. So it is something like this. So how we take cross product? If this is e1 cap, e2 cap, e3 cap, e3 cap, then if I take dot product, if I take cross product of e1 cross e2, then it will be e3. Okay, if you take a reverse e2 cross e1, then it will be e3 but with negative sign. So sequence matter in cross product. So that is how we take here cross product. e2 cross e3 is equal to e1 cap. Then from this I can write e1 cap, this one I can take these quantities here. So it will be h2 h3 del bar of u2 cross del bar of u3. So this is for e1. Now I obtained some expression for E1 cap. This expression I am going to use over here. That is first term of divergence. So I will carry that term over here. So I can write it like this: del bar dot F1 E1 cap is equal to del bar dot F1 as it is, then E1 cap from here. So it will be H2 H3 del bar of U2 cross del bar U3. Okay, I will use square bracket over here. So something like this we will get. Now there is some formula you can call her. If del bar is operating on some scalar function phi and some vector function psi, okay, and there is a dot product of del bar with this quantity, then it can be expanded as del bar phi dot psi bar plus phi del bar dot psi bar. Okay, so here you can see del bar is operating on phi. Using this, you can consider this as this quantity. So this quantity is phi, this quantity is psi, because you can see it is a vector and it is scalar. Now I can use this, and then I can write this term here. Okay, so it will look like del bar, then phi, that is F1 H2 H3, this is phi, then dot psi bar, so this is psi, dot del bar U2 cross del bar U3, and there is addition, then phi, this one is a phi, F1 H2 H3, del bar dot this quantity, so I will write it here, del bar U2 cross del bar U3. This product, okay, this dot product goes to 0. How? Because you can see in del bar U2 there is del bar U2 contains E2 cap upon H2 and del bar U1, so there is U3, so U3 contains E3 bar upon H3. Okay, if I take a cross product of these two, then it will give me E1 cap by H1 H2, and if I operate del on this quantity, okay, if I take dot product of this, you can see I have to take with dabba by dabba U1, but there is no U1 in this quantity because this contains U1. So okay, we have not written any expression for del, so I will take it on next page. So we were here and we were operating del on this quantity, which is a product of this. As we know, del bar in orthogonal curvilinear coordinate system is E1 cap upon H1 dabba by dabba U1 plus E2 cap upon H2 dabba by dabba U2 plus E3 cap upon H3 dabba by dabba U3. So this is the expression for del bar. I am operating del bar on this quantity. As I am taking dot product, so only the quantity which involves E1 cap will survive. So you can see this quantity will be there, and you have to take differentiation of this quantity with respect to dabba by dabba U1. This doesn't contain any U1, right? You can see it is a 1 here, so differentiation will be 0, so it will go to 0. Now I will carry this term as it is down, so this will be del bar F1 H2 H3 dot to cross del bar u3. So this was for del bar dot f1 e1 cap. So I got this. Now I know that cross product of this is this much, right? So we have done it here. You can see the cross product of del bar u2 plus del bar u3 is e1 cap upon h2 by h3. So I can write it here, del bar f1 h2 h3 dot e1 cap upon h2 h3. Okay, so in dot product sequence doesn't matter, so I can take this term here and this one here, so it will look like this, f1 e1 cap. Okay, so we are doing it for first term of this expression. Okay, we are doing for this, so this is the first term, and for that term we have obtained this. Similarly, for second term I can write del bar dot f2 e2 cap is equal to e2 cap upon h3 h1 dot del bar f1 h3 h1. For third term, del bar dot f3 e3, it will be e3 cap upon, so h1 h2, here will be dot product del bar, here will be f2, here will be f3 h1 h2. So these are the three terms which we have obtained. Well, we have an expression for del bar. Okay, so expression for del bar is this. I can use this expression over here. Okay, and also for this term, for this term. So what I will do, I will work out for this term. Okay, in this term I will put the value of del bar. Rather than value, I will put expression for del bar. So del bar dot f1, I'm carrying this here, e1 cap is equal to e1 cap upon h2 h3 dot. So now I will put e1 cap upon h1 dabba by dabba u1, this is the value of del bar, plus e2 cap upon h2 dabba by dabba u2 plus e3 cap upon h3 dabba by dabba u3, and this is operating on f1 h2 and h3, f1 h2 and h3. Okay, now as there is a dot product, you know that only the terms which contains e1 e2 will survive. You can see there is no e3 term in this first quantity, so it will look like 1 upon, and also dot product gives you scalars not vectors, so direction will not be included in that. Then it will be h2 h3 and then h1, so even cap will not be there, dabba by dabba u1, and these two terms will not come because our first vector does not contain e2 and e3, and then it will be operating on this f1 h2 h3. So I wrote it for first term. Similarly, we can obtain for second term and third term. Then overall expression for del bar dot f bar will be, it was like this. I will write it again, f2 e2 cap plus del bar dot f3 e3 cap. Okay, now I can obtain such expressions. This is for first term, right? So you can see this is what I have obtained for first term. Similarly, I can work out for second term, I can work out for third term. Then overall expression for divergence, we are taking this quantity means you are taking divergence. Okay, so I can write it like this: 1 upon h2 h3 h1 dabba by dabba u1 of f1 h2 h3, right? Okay, similarly for this part it will be 1 upon h2 h3 h1 and then dabba by dabba u2, then f2. Here it was h2 h3, so here it will be h3 h1, and the remaining will be 1 upon h1 h2 h3 dabba by dabba u3 f3 h1 h2, and this is the expression for divergence of vector f bar. Further, from this expression I can take this one and this one common. So I will take h1 h2 h3 common. Okay, h1 h2 h3 h1 h2 h3 and h1 h2 h3 from all terms, and then it will be dabba by dabba u1 f1 h2 h3 plus dabba by dabba u2 f2 h3 h1 plus dabba by dabba u3 f3 h1 h2, and this will be the final expression for del bar dot f bar, that is divergence of vector function f bar in orthogonal curvilinear coordinate system. So today we will stop here.